Okay, it's great to be here and to have the prior speakers make my job so easy. There's not much for me to tell you left on. But hopefully I have some things to add. I'm from the University of Colorado in the USA. The title of my talk here, What Will Happen When We Successfully Slow Down Ovarian Aging. It was fun to think about it and think really positively. We tend to, as a community, to think about, the doom and gloom, the negativity, and our clinical colleagues, their patients have real problems that they see every day. But the question is, what's around the corner and what can we look forward to as we solve this problem? So we have actually, and I'm proud that my lab has successfully slowed down ovarian aging in mice. And ovarian aging has been slowed down in human beings in large populations by the intake of moderate amounts of alcohol. So women who drink alcohol moderately have menopause about 1.5 years later than women who don't. So there's a natural
Any recommendation of the alcohol?
And one might think, oh, this is the Mediterranean diet or red wine or something, and not at all. No, it just happens to be the ethanol, and we can speculate about why that occurs. But there are ways to slow down ovarian aging.
Ladies, we're drinking tonight.
So there are really reasons for optimism, including very sophisticated techniques that Victoria talked about, and Songwei and myself I've worked on too. So this should be an optimistic place we're coming from. I focus on egg quantity. I don't think about egg quality usually. And I'll give you a specific example of why I think that's useful. Of course, if we are, we see a nail that is our patients who are having trouble conceiving, we want to fix it with our hammer of ART. But today, I'm here to talk about egg quantity and how the supply of primordial follicles is regulated in this very interesting way. So I focus on the rate that primordial ovarian follicles commit to growth activation. I'll show you a simple scheme in a moment. This is indeed the primary driver of ovarian aging, at least the way I think about it. A fixed fraction of primordial follicles out of the total remaining pool begins to grow each unit time. And the question is, can we change this rate per day, per unit time? And you can slow it down with different interventions. So diet, metabolism, alcohol, are there medical interventions? Does stimulation, do hormonal interventions change what's going on with primordial follicles? As Songwei mentioned, hormonal contraception, the answer is no. Primordial follicles tend to ignore what's going on around them and just growth activate out of the total remaining pool. And is there something we can do for all patients? Are those who there are mechanisms going awry that can't be addressed? And that's an interesting thing. So I really like to get simple when I depict and think about ovarian aging. Per ovary, about 250 primordial follicles will begin to grow for every one that produces a mature egg per month that might get fertilized. And I'm sorry about the formatting of my slides here. This is 1 million. I don't have a pointer, but there's 1 million primordial follicles depicted at left. Of those, every unit time, some begin to grow. The red ones die, the blue ones continue to grow and go on until we've reduced these down to the one that might get fertilized. And then certain women, if I go backwards and compare, certain women are born with closer to low hundreds of thousands of follicles, and instead of 1 million here. So I'm just showing the comparison. Similar fractions over time get down to still that remaining one mature egg per month, despite this difference of 10-fold. This is the first step in my depiction. And the single step that I'm asking you to focus on, why does an individual primordial follicle decide to grow when a girl is 13, but a follicle physically touching it inside the ovary here right next to it won't begin to grow until she's 56? Interestingly, those can grow when she's 66, postmenopausal. Follicles remain in the ovary, they're very rare, but growth activation can occur postmenopausally as well. So in my lab, we use models. I'll show you the example of galactosemia, a disease where these follicles, this process goes very quickly, and we intervene using a chemical. We try to get at mechanisms and then translate that maybe to the clinic. So galactosemia, classic galactosemia is a loss of gene GALT. It accelerates ovarian aging at the level of primordial follicles. And the mechanisms here aren't entirely understood, but in collaboration with Kent Lai at the University of Utah, we've shown that you get slow ovarian aging in these animals. In women born with galactosemia, they're immediately as babies taken off of their mother's milk containing the sugar galactose. It's toxic to the baby and it'll kill the baby in a matter of days. Given that you're taken off of galactose and grow up, one of the remaining problems that these people have, although they're quite healthy, is they tend to have POI with a median age of 19, right? So extremely severe. Early loss of primordial follicles despite being born with approximately normal numbers. So these mutants, both mice and women, experience a faster loss of primordial follicles, 80% earlier loss of fecundity compared to wild-type controls. Our small molecule intervention, this is all published. The molecule we use was salubrinol. It was originally tested to block endoplasmic reticulum stress. It turns out it's an integrated stress response inhibitor. And we found it was able to normalize both the rate of primordial follicle growth activation, also the maturity. In my cartoon, those dots maturing, it normalizes the numbers that grow to release mature eggs in mice. That's 10 to 12 per cycle. So normalizing the rate of those follicles that they grow and maintaining their quality, giving you normal litters. This is all published. I'm going to show you some of the data in a moment. I discussed why egg quality is different than quantity here. But we're getting more eggs out of the animals kept off on salubrinol. This is a superovulation experiment where wild-type animals aren't harmed by the drug, but galactosemic animals rescue the numbers of follicles. These animals were kept on salubrinol from the time of birth, and then at 10 weeks and beyond, kept in breeding trials I'll show you next. So there are more pups, and these are more healthy pups given organ weight. And while untreated animals would stop having litters, we had continuous litters. So this is a rescue of all of ovarian function, and critically, primordial follicles were normalized and growth activated in the expected pattern. We protected egg quality, all of that was fine. So if you can normalize, if you can, as Vittorio showed us, if you can deliver new follicles that behave normally, the prospects are extremely bright. The question is, can we have them behave normally? Can we deliver the somatic cells needed to form new follicles that will behave normally? So I mentioned at the beginning, is there any case where you might like to slow down the loss of primordial follicles, the reserve, but not maintain egg quality? Sure, women who have had their children and don't desire children in the future, poor egg quality is not a negative. It's compatible with her current choices, right? And so it's not necessary that we always protect or have maximal egg quality. It's just one way we can measure that we're producing normal follicles. What percent of eggs are good in women normally, right? In the best case, it takes several months, even conceiving at home for young people, right? So egg quality in humans is terrible, on the order of 50% or worse in the healthiest women. So our target doesn't need to be 100% good eggs, and it can be worse than that if someone's not seeking to conceive. All right, so here I'm generalizing interventions, and we're moving to sort of the mathematical modeling work we've been doing recently. I should have included a slide. We have a paper in Science Advances in January of this year where we were able to recapitulate the normal patterns of ovarian aging across populations by modeling what primordial follicles are doing. By modeling primordial follicles, we're able to produce the pattern of the age of natural menopause across the female population, including different ethnic groups that Zongwei told us about. but also the patterns of menopausal transition. So the same model gives you the output of when periods become irregular and then when periods cease. And again, we can do that simply by modeling what primordial follicles are doing. But as far as interventions, this is not as sophisticated as what's being done in wet labs that we saw, but we can take three approaches here. We can have a drug to slow the rate of primordial follicle loss, and we refer that to generally as a slowing approach. We could pharmacologically increase primordial follicles, or use cell therapy or engineered techniques to produce ovarian cortex, to fill that with engineered follicles, right? And we refer to the latter examples here as boost strategies, where we're increasing the number of follicles. And again, we'll consider how they behave once we've boosted those numbers. So, what is going to happen when we slow down ovarian aging in women? This came up earlier too. We'll solve certain diseases that arise as a result of ovaries failing. We'll reduce the incidence of diseases that begin to go up with menopause and alleviate a group of symptoms associated both with menopause and those diseases that we're getting rid of. After a very careful safety assessment, considering that there are risks with ongoing menopause as well as benefits, we need to get at some fundamental questions, and I'll deal with three today. First, who needs the intervention? Right? A woman is going to have menopause when she's 54. When she's 40, she doesn't know that. She does not need to begin an intervention because she's going to hit menopause when she's 54. Again, we just haven't identified who is who yet. A woman who is 40, who's going to hit menopause when she's 42, what absolutely is our target, right? That's the people we're trying to help. So identifying who is really important. So if and really when rapid progress occurs in this area, well, if we have total command of the situation, how much should things be slowed quantitatively? How many new follicles should be added? How much drug should I take and for how long? What age should I start? Right? Will there be recommendations that young women start a drug right away who we've identified as having diminished ovarian reserve, let's say? So a very busy slide, and I won't read what we're going to solve here. But there are many, and they're extremely impactful things that women deal with who have menopause, much less, at the POI age of 40. But if you're in your 20s and you have hot flashes, loss of bladder control, these issues with libido, sleeplessness, etc., these are extremely impactful things. This, again, we're thinking positive. This is what we have to look forward to solving for these people. Wow. Sorry about that. All right. And so, some language from a recent paper is at the bottom here, presented with, whoops, I should pause. I did already mention that, yes, there are consequences. There are not only benefits. Extended exposure for estrogen does give some enhanced risk to estrogen-dependent diseases like breast cancer, but those, as large data sets are being reanalyzed, are thought to be less important than they were originally, but presented with an accurate risk assessment, includes family history, individual genetic information, and critically, actionable information about their own risk for menopause and how soon, women consider the age for the interventions we're considering that's appropriate for them. All right, fundamental question one, who needs and what type of intervention? This is very simplified, but if we consider age 40 and before as early loss of ovarian function, 51 the current median age of menopause, 62 the world record approximate age for menopause, I can draw this simple red triangle that the earlier you are on our timeline here, the more likely you are given a loss of ovarian function to desire intervention, right? So this is our time frame, and this is the proportion of women as we approach the median age. I think women are less likely to consider the need for intervention. Back to how we would do it, we mentioned we could have drugs or cell therapy-based approaches to intervene and slow things down. So now the fundamental question too, quantitatively how much should we slow things for our patients, for their patients. And we can draw the delay here as this gray arrow. And I think it's very reasonable to consider delaying things to the median age, right? That's a conservative view of looking at things. Getting anyone whose ovaries will fail below 40, maybe in her earlier 40s, to the median age. We're not talking about a lot of increased risk. It's the current median age. I think that's, again, conservative. Is there risk involved in taking theoretically every woman who is going to have menopause prior to age 40 out to this world record age at 62? Right? Maybe. I don't, thankfully for myself, have to make that decision, but a family member that I really cared about, this is what we're going to be faced with. Delaying things to the world record age for everybody, seems reasonable, but there may be risk we have not, anticipated, so it's worth, I think, including today. So the mathematical modeling that I mentioned allows us to do some things to, again, give rise to the natural distributions of these landmarks of ovarian and reproductive aging in women. But we can also model, and this tool is available online. I can give you the QR code or the link. This is getting ready to be submitted for publication. So if we have a slowing therapy, we can input in this interactive tool developed by Sean Lowley in Utah the age that we start our therapy and the percentage of slowing of ovarian follicle loss that we're inducing by being on the therapy. So if you can start your model here as early as age 25, as late as 45, and it gives you an interactive plot here, as well as a prose description, given an intervention that slows the primordial follicle loss by 25% that starts at age 35 and lasts until menopause. The middle 80% of women would have a distribution of menopause ages from 51.2 to 61.7 years. So there's output, again, that's interactive. This is more relevant to the cell therapy approach we saw. And here, the age that you boost the number of your primordial follicles, the number that you do so, the number that are delivered, and importantly, the relative aging rate as a percent of normal follicles. If the new ones you put in age or are lost twice as quickly, what's the impact? If they're lost half as quickly, if we can engineer them to behave and grow more slowly, I think that's useful to consider too. And in the same way, we produce this interactive plot of the likely impact on the menopause, and it's delayed due to treatment. And this is summarized, the same sort of interactive things, but summarized overall, and it just allows me to make some broad claims that are intuitive. In terms of boosting new follicles, the later you intervene, the greater the benefit. That's intuitive. Again, if you had the same number later, right before you had menopause, all of the benefit or all of the time those follicles are going to work start when you deliver them, and the greater the benefit you're going to have in terms of a menopause delay. Instead, a pharmaceutical approach or other that slows the loss of primordial follicles, the earlier you intervene, the greater the benefit. And when acting upon a higher initial reserve that we can only measure indirectly, I'm going to show some AMH data in a moment that'll emphasize why this is important. So a woman with a higher initial reserve will have a greater benefit given the drug started at the same age than a woman with a lower initial reserve. And given advancements in this area, the more advanced the intervention, the greater the benefit versus these constraints of time and initial reserve. And initial reserve we only can indirectly estimate. So now our fundamental question 3, who is who? Who needs this intervention? A lot of wall of text here. There's little warning that menopause will happen for women at any time, right? Often very early menopause is a complete surprise. In women's families, we have menopause in our 50s, or right? In our family, we tend to have it. My aunts and my sisters had it in their, around age 45. But women who receive REI workups, some of whom are currently seeking to conceive, perhaps they have a partner with male factor infertility, right? And at the same time, their male partner is found to have a low sperm count, they realize they also have a low ovarian reserve, just by luck. They may leave with a baby that cycle, but have this information. So these women have more information than almost anyone else on Earth with regards to how long their ovaries are going to work. So all of those women and many women who don't have any information, of course, would benefit from slowing the rate of primordial follicle loss or using technologies to deliver more. So we're going to finish up by talking about AMH here, and how precise is AMH in terms of thinking and predicting the remaining ovarian follicle reserve. So even from the far back of this audience, you can see these data are quite noisy. I included the example on the left where the data are shown on a log scale. The time frames here are similar from very early in life until age 51. The non-log scale data are still very noisy, but by age, it's easy to appreciate that women can have 10-fold more AMH at the same age. And Zhong Wei could tell us, how imprecise this is in terms of when each of those women will hit menopause. And you can do serial measurements, you can measure monthly for 6 months, and not do much better in terms of any precise information about when any of these women will hit menopause, nor where the number of primordial follicles they have. This is the state of the art, approximately. And I do want to read this because I think it's really important. And this is because it's a recent study done with large numbers and trying to figure out, as precise or large data that they had with AMH numbers across their patients, what could they say about ovarian reserve? Very little. But they could say AMH levels measured in the late premenopausal period are inversely correlated with the time to ovarian senescence. That's quite general and not quantitative in any way. However, AMH levels, this is useful, actionable information, measured in the perimenopausal period, are inversely associated only with the severity of symptoms. Right? The cutoff of 12.012 nanograms per mil AMH predicts menopause with low sensitivity and specificity, making it challenging to use in a clinical setting for that use. However, identifying women at higher risk for symptoms given their AMH is useful, just not for what their ovarian reserve looks like. So, determining who needs what type of intervention is critical. Once we know that, how much ovarian function can be slowed using novel technologies, whether pharmaceuticals, like I talked about for galactosemia. I'm funded by AthenaDAO to test those same approaches in wild-type mice and normal mice and extend that screen to natural products that target the same integrated stress response. And given the answers to the top two questions, all of us in this audience agree we can have massive benefits for women's health and indeed equity. So we want control over the situation. Things are out of our control. We wish we had more information so we knew what to do and for who. And we had later age of menopause, longer reproductive lifespan between those markers, associated with a higher likelihood of survival to age 90 among postmenopausal women, right? And won't it be great to have women who are outside of this span, to get them inside of the span and help them live healthier lives, and they'll make it more likely they'll be healthy and make it to 90. Finishing up, these near-term interventions absolutely can slow the loss of primordial follicles. Very soon, clinically, I would agree that we will boost numbers of follicles by delivering lab-generated new follicles, ovarian tissue, etc. And we need to translate these experimental strategies in a safe way to the clinic. These interventions can enhance health equity during aging, reduce the limitation that's been covered so well by prior talks, and then I just include the point that protecting or enhancing egg quality is important for infertility patients, for people who are struggling conceiving, for people who would like to conceive later. It's not relevant to everyone. So the target, I think, is not quite as stressful as we need to make it. So I can finish there. These are the collaborators and colleagues in funding do this work. And again, I'm happy to share that mathematical modeling paper or address any questions now. Thanks very much for your attention.